Hey gang, David Chandler back with you. Today I'd like to share with you a pattern that I found pretty useful for getting data into BigQuery. A lot of times data comes from some kind of an external system via an API. And so when we're pulling from APIs, typically on a nightly basis, one of the things we need to do is make sure that we always have a way to catch any errors. We want things to succeed as much as possible. We want to capture the raw data from the API, even if it may not be perfect, that there's errors in it or format things that we're going to need to change later. We only want to call that API once and capture that raw data. And then we want to clean up the data. And traditionally, we call this ETL or extract, transform, load, do transformations on the data, and then load it into BigQuery. So I just want to show you some patterns that I found useful for doing this. So we're going to start over here with the API. We have an external system. In the example I'm going to show you, we're looking at ClientTether, which is a CRM. One of my customers uses that, and it stores all of their current sales opportunity, as well as proposals that they've issued to customers and payments that customers have made as well. And we use the ClientTether API to pull all this data every night into a BigQuery data warehouse. Now, the code for this section, let's have a look at it here. It's actually pretty simple. I'm using Python pandas to do this, and we can pull it in to data frame. So this is really neat because data frames make it really easy to work with BigQuery. So you can see the important lines here from the API call. We have this JSON normalize, and we take one property of the API response. Their field is just called data. That loads it into a data frame. And from there, we can actually write that data frame. If we scroll up here to the write method, we call BigQuery client.load table from data frame, and we can actually take all the data in that data frame and load it directly into BigQuery. So this is a super easy type of code to write for getting data into BigQuery in the first place. So that's step one, is making the actual API calls to get data in. Where we put that data now is into a raw table. And in this table, all the column types are string. And the reason why I do that is because I don't want to lose anything due to format errors. Let's say we were reading data from the API and we were expecting it to be numeric, but for some reason in the CRM system, somebody put a non-number in a numeric field sometime, right? And a lot of times on these systems, data validation isn't that great, and that might happen. What would that do to our import script, right? It would blow it up because it's going to cause an error when we try to load that into BigQuery. So instead of loading directly into our final BigQuery table, what I like to do is put it in a raw table first, where all our data is in string format. And that makes it much easier to go back if we need to make any changes format-wise. We have still the raw data captured in this table. The other thing that's nice about a raw table here is that it lets you see all of the data that you've pulled in this particular run. So sometimes you get done loading data into your final table in BigQuery, but then you want to go back and ask exactly how many new rows were there last night and which ones were they. If you have all the data sitting in the raw table, easy peasy, right? You just look at that table and that shows you exactly what got loaded into your database last night. Another reason that you might want to have this is because things can change in your business rules. So maybe you realize, oh, we need to do something different with the raw data. You've still got it there in the raw table. You've got it captured, so you can run different rules on it. Maybe you made a mistake in your original import process due to a new feature you're adding. No problem. You can back that out easily because you still have the raw data capture. So it always lets you go back and see yesterday's data or however often you're running these things. The next stage in our import pattern here is a SQL view that does all of our transformation. And this is what I think is really the neatest in BigQuery. So let's look at an example of that as well. We'll go to our opportunities most recent view here for that raw opportunities data. And you'll notice there's a lot of functions in here like trim, safecast, safe parse for the date times, etc. And that's very intentional. So this is where we're going to transform our strings into their actual native types like floats or integers or dates and times. And we use the safe versions of these things as much as possible in order to prevent errors. Again, because we don't want our load script to fail. We want it to work. And then with the safe functions here, you would just get a null value if some value is invalid. So this makes it makes your data a lot cleaner going into the final stages of processing. The trim function is also really important here. That just does left and right trim of white space. And you'll find that in the real world, people are entering data in the field. A lot of times they have extra spaces. Maybe the system itself puts one in. Maybe somebody just types an extra space without realizing it. Trailing spaces are the worst. They're really hard to find sometimes. And sometimes you're joining that field on another table in BigQuery. And guess what? The join is not going to work if one of the fields on one side has a trailing white space and on the other side it doesn't. So I've gotten in the habit of just trimming everything, makes it a lot easier. Everything that I'm going to need to join on for sure. And that'll help my reports work better. So one of the things that's really nice about this pattern here of using the view to do all the data transformation, it's not an extra table, doesn't cost you anything for storage, and it lets you make updates very quickly. All I have to do if a format changes is come in here and change it one place in the view. And furthermore, it's just a change to SQL, not to an underlying system. And that also is a benefit because a lot of times it's more difficult to push Python code, new versions out there, but it's very easy to make a change to SQL. You can also test it very quickly. So I really like this pattern of doing your transformation in a view. You'll notice here, I'm working in VS Code and I work a lot of times on the terminal, not in the BigQuery console directly. So typically when I'm first creating a view, I'll work in the BigQuery console directly to get the benefits of syntax highlighting and things like that from the editor. But thereafter, a lot of times I'll just come in here and run BQ on the command line. So we can run something like this, BQ query, and read data from this file, opportunitiesmostrecent.sql. I'll just go ahead and do it here in my dev environment, and it immediately replaced that view. The nice thing about this, if I'm making little changes and maybe testing them in another window with my reporting interface or in a BigQuery, right, I can just come in here, make the changes quickly, come back, hit up arrow, and load that view again. And that's actually faster a lot of times than working even natively in the BigQuery console and having to replace the statement every time. The other thing I like about this pattern is, of course, it gives us integration with Git here in VS Code. So I can quickly see all the changes that I've made. And when I'm done making changes, I can then go commit those into the Git repository. So I have saved the current state of the view in Git at all times. And that way, if I do make code changes down the road, I have that history to go back and look at. The second part here that's really nice is the SQL view with all of our trims and safes in order to pull the data in more reliably. From there, what we do then is a merge statement to take data from the raw table and load it into the historical table. And so that merge statement will actually select data not from the raw table, it will select it from the view. So now we're dealing with transform data, we're dealing with the correct data types like integers and floats, and we're merging that data into our final historical table, which has those correct types as well. The reason we like a merge statement is because this is a single SQL statement that can read in many thousands of rows, millions of rows, really billions actually, if you get down to it in BigQuery, but it can do them all in a single statement. And you know that BigQuery is not designed to be a transactional database. It's not designed for those row by row inserts and updates. It's designed to read data in batches. And so that's what we're doing here. We read data in a batch. We call that BQLoad function once to load thousands of rows into our raw table. And then we're going to call the merge statement once to select data from the view and load it all in one statement into our history table. So this helps query to be efficient. It also allows us to deal with the fact that new data from an API typically has a mix of updated as well as new records. And the merge statement is designed for that. So we have a condition here at the top of the file that indicates what we're merging on. In this case, if the opportunity ID for every sales opportunity and the sub-account location match, and the modified date is more recent than the modified date we have in the historical table, then it's going to update because this is an updated opportunity. And so it just updates every field. If there is no match in the historical data table, then our merge statement just inserts the entire row. So very easy, one statement that can read all the data, transform through the view, and load it into the historical table in one fell swoop. So that's really it. That's a pattern I found very useful. It's relatively simple, easy to understand, and gives you a lot of benefits in terms of being able to go back at any given point in time and see the status of things, make changes easily to your transformation logic, etc. Hope you find that useful. If you have any questions, put them in the comments.